Okay, let's talk about evals. So today's session, the way I want to do it is, I want to focus on the basics of evals, what we try to do in terms of, when we think about evals in general, and then I want to give a short demo of building evals. Building evals takes quite a lot of time, so I've created some notebooks, some sessions that I've already prepared evals. I'll quickly walk you through my own notebooks and my own eval sessions. That's what I want to do. So yeah, coming to evals, right? Evals is, like Bala rightly pointed out some time back. Evals is quietly deciding how the product lives or dies. Leaders in the AI space, right from Kevin Will, OpenAI CPO, when he spoke to Lenny, or Anthropic CPOs, like the leaders in AI keep talking about how evals are the real moat, or are the real game changers for AI applications and AI models as well, right? The foundational models as well, and getting evals right and wrong makes hell lot of difference in terms of how the product works, right? So absolutely, evals are important. I think there are no two ways to think about it. Now, broadly, what are evals, right? I'll start with some basics about evals. So evals are essentially ways to test or check. Evals is just a short form for evaluations. Honestly, it's a way to test or check how well your model or application is performing. Uh, if you think about evals, we have three areas under evals. Number one is the general evaluations about how well your models are performing. But then there are also two other areas that have kind of got under evals in a way. One is observability. How's your model in terms of system metrics, performance metrics, etc. That's also coming under evals largely now. And the third one is responsible AI. Responsible AI also comes in a way under eval. You talk about your safety evaluators. You talk about how if there is any adult content generated by, or adult content passes through the filters, etc. Right. So all the three fall under evals. So we'll focus today primarily on the basic evaluations. We will, if time permits, we'll talk about safety evaluations and observability, etc. But we'll focus primarily on the basic evaluations. Cool. So let's talk about why are evals complex, right? Before we get into how to build evals. So I try to split evals into three phases based on my own experience. So traditionally, when I started product management, we used to do a lot of software testing, which was the traditional evals. And then came the world of predictive ML. You were doing forecasting, you were doing predictions around whether something will happen or not. So that's your traditional ML models. Your random forest trees and all of those. And then now we've come into the time of LLMs and agent evals, right? So broadly, and again, honestly, the world of evals have changed so much from the predictive ML to the agent evals as well. So I want to cover that also for folks who probably worked in building predictive ML models, but not worked so often in building agent evals. So like we all know, software is largely rule based. You give an output, you give an input, you get the same output every time you give the same input. Predictive ML, non-deterministic evals, agents are also non-deterministic. It largely changes based on how the agent works, or how the model works, and how the inputs are given. One of the key differences is software testing. The code paths are predictable, right? You have a certain workflow in which it operates. Predictive ML also, good thing is it is predictable that way, right? If you think about how predictive ML works, you have a large data. You have some data point that gets featureized into some understandable data points for the ML, which then the ML model, which is trained on a certain data set, uh, consumes and then gives you an output, right? So there is a certain path in which it goes. There's no variation in the paths, right? But that's not the case with agents. Agents have multiple paths, starting from how does the agent understand an intent, right? You give an intent to an agent. Let's say there's I've given an example of a trip planner agent, right? So you ask an agent to plan a trip to some location. How does the agent understand the intent? Does it include planning a trip? Does that include hotel booking also, or is it just booking flights, right? So agent determines the path, or the LLM underlying understands the intent. They determine the path, and then depending on the available tools, they keep calling different tools. And this is what we call as trajectories, right? They may follow different trajectory based on the intent that they understood, and then they come to an answer, right? So now it's unlike your predictive ML, where you set the path about featureizing, prediction, and then giving the output. Here the LLM kind of decides the path, right? LLM understands the intent. LLM, based on whatever it understands as the intent, it decides how the progress should be. So this multiple paths is a key difference, right? This is where evals are getting much more important than how much importance evals had during the predictive ML days, right? Um, going forward, since software is rule based, predictable, you have existing code base, you follow the documentation, you write test cases. As simple as that. You test all the if else loops logics that you have, and that's about it. Predictive ML relies on data. You have to get a wide variety of data. You still had to think about statistics, random samples. You still had to think about distribution. Is the entire distribution of the production or the population, is that represented in the samples? You have to think about all of that. But still, it was largely easier because if you think about it, when I used to build predictive ML models, we used to outsource a lot of these data generation, right? We'd give it to we'd give some rules as to how this can be done, and then outsource it to third-party teams who would have humans who'd label this data and say, hey, let's take an example, right? Let's say I want to figure out whether a given page. One of the problems I used to work on is whether a given page on an e-commerce website, is it a product page or a non-product page, right? So it was easy to just get a list of URLs, give it to humans, and ask them, hey, can you label this as product page or non-product page, and use that as an evaluation for how well my ML model was performing, right? But that's not the case with agents, right? Agents, it's harder because how the agents is product page prediction the real problem? What is the real problem? How should the intent be understood? We need to test a bunch of things, right? So again, that's different. And lastly, contextual software testing is not at all contextual in my not to say software testing is easier. It's less contextual because there's a set of rules that you follow, whereas predictive ML has some context, but again, the workflow is typically linear. It's not a complex graph-based workflows, whereas agents is pure graphs, right? You typically, and if you're uh, uh, typically building an agent, you're calling multiple tools, taking decisions along the way. So that's important. Moving on. So let's focus on the evals piece alone, right? What are the types of evals? There is offline and online evals. Let's talk about different evals out there, right? And how we'll also talk about how we can build these. So first one is benchmarks. You might have heard of popular benchmarks. Let me show you, all these leaderboards that are typically that you see are all based on some benchmark. There is either the models compete against each other on a particular task, or there is a benchmark data set. You might have heard of data sets like a Google Proof question and answers, which is the GPQA data set, or you might have heard of MMLU, which is multi-language data sets. So these are data sets that humans have prepared, where there is a certain set of questions and certain set of answers that are assumed to be correct, and we test how the LLMs or even the agents perform on these, right? Some of the more popular ones for agents is you have your browser use data sets, which OpenAI has open sourced, right? So how well, if you build a browser use based agent, and if you give make it work against that data set, and then you can actually see how well that model is performing, right? Another popular one that's coming these days is the humanities last exam benchmark. So this one, see some of the data sets that I talked about are here, right? So this one is technically much more harder in terms of the answers to these questions are not available online, obviously, but the answers to these questions are probably PhD level questions, right? They're PhD level questions and answers, right? So that's why you'll see even the top models not really cracking this and getting to 100%. Whereas we spoke about GPQ, which is Google Proof Q&A, and then math and MMLU models, MMLU benchmarks against which most of the top models these days do a good 80% and sometimes even 90%, right? And this is inherently, if you see, there is a problem here, right? The benchmarks are getting outdated. models are performing really well on benchmarks, and that does not mean the benchmark is bad. It just means that the benchmarks have to be improved, right? You need to add either more complex questions, either more diverse questions, either more scenario based questions. So how do you make it, as human like? How do you make a benchmark as human like as possible, so that when a model or an agent tests itself against the benchmark, we can kind of say that, the agents or models are also performing at a human level, right? Uh, yeah, the HL is an interesting one. If you get a chance, just go through some of these questions. They're very interesting. I don't think I would get a 20% on this, though I'm a human, so I don't know how human this benchmark is. Worth trying sometime. So another one that I dabbled with, I want to quickly talk about this, is a DAP step. So one of the problem statements that I'm working on is converting natural language to SQL. So it's like an analyst kind of an agent that I'm exploring, and there's an open source data set for that. It's called the DAP set. The DAP step. What this does is it gives you a bunch of data sets, and on those data sets you can ask natural language questions, and it gives you what could be the potential answers and how those answers were arrived at. Right? So if you have an agent which was able to convert natural language to SQL, uh, uh, the application makes a call to the table, get the answer, understands the data, and then generates, say, a graph or some kind of a chart. You could use this to really test how well that is performing, right? So this is all about open source benchmarks, right? A lot of open source benchmarks available out there. We could always reuse them if there are generic use cases that we're working on. But then oftentimes we're not working on generic use cases. We're working on company specific use cases where we have to create our own data sets, right? So how do we do that? We do something called synthetic data, right? Because we don't have enough customer data out there. We might not have enough customer data out there, and how can that be converted to? How can we generate synthetic data using some of the ideas that we have? How do we, based on those synthetic questions that we generate, how should the answers look like? How do we create, and that's what is called as the golden answers, the goldens. And then eventually, how can we rate outputs, use LLMs as autorators? So those are things we'll talk about. I'll show a quick demo on that. Let me actually show something that I built, right? Uh, okay, so as I said, one of the use cases that I was working on is converting natural language to SQL, right? So there is an accounting tool that we're working with, where we're trying to see how we can improve generation of insights or generation of answers to questions, right? So think of a tool like Zoho Books or QuickBooks, etc., where you have an accounting tool uh, where you have a lot of financial data, but then you want to generate insights from the financial data. For instance, you want to say, hey, your revenue is going good, which is great, or your COGS is going higher despite your revenue being constant. Your cost of goods sold is growing much faster despite revenue being constant. Or let's say the accountants want to ask question, hey, is my account receivable days, are they good or are they bad, right? So how do you kind of figure that out and also benchmark it and say how good or bad it is, right? So a lot of questions that we realized are more higher order questions like, when we start talking to customers, we realize that people start asking questions like, how's my business doing? How good is my business? How do I improve my business, right? These are really higher order questions, right? You need to understand different parts of the business, and a business is a holistic of multiple and what do you call KPIs, right? A business can be doing good if the revenue is going up, the cash flow should also be going up. Say the cost should be going down, profitability should be going up. There are multiple things that you need to consider to say whether a business is doing well or not, right? So what we were trying to kind of build was on the lines of deep research. So can we take a higher order question, break it into multiple smaller questions, and then each of those smaller questions can be broken further, and you can take uh, various paths to go and explore on those lines, come back with an answer, come back with all of those research that you've done, and then generate an answer overall. This is one of the use cases that we work with. So here, I obviously this is edited prompt, I started with a very, very basic prompt on ChatGPT. That's how I started building this data set. I started with a basic prompt of, hey, I want to generate this eval data set about which considers a bunch of which generates a bunch of sub questions when I give an Uber higher order question, and that's how I started, right? So interestingly, the way ChatGPT solved this is it understood that the underlying need is to create an eval data set. It started asking some questions and then gave me some examples. Is this is what you're looking at, right? So once I started looking at it, I realized some of these were right, some of these were wrong. I gave that feedback, and ChatGPT started, understanding based on that feedback. And what it started doing is it started giving me some ideas as well, which I was not considering, but these are great ideas to consider. It also started asking, hey, should I rate the difficulties? Most of the benchmark data sets, if you go and look at them, they also have difficulty levels. There are easy, medium, hard, and based on how the agents solve those easy, medium, hard questions, the overall rubric is created as how they, what is the performance of those agents, right? And then it started telling me, hey, I can give you a CSV style data set, and I can give you a scoring rubric, and I can also mark it across different levels, right? So I started generating this, but then I wanted it to generate it a lot more questions. It was generating much lesser questions in terms of, it gave me like 10 questions or so. I wanted more questions. I wanted more detailed sub questions. I wanted more detailed, combination of internal and external questions, right? So I started asking it. Once I started asking those questions, it went into a plan mode. It began in agent mode by itself. So it said that, hey, I'll create, expand to more questions. I'll create more sub questions. I will also share the data in formats that you want, but I'm going to take some time to do it. So it took some confirmations, and you'll see that it said, I'm going to generate these complex questions. I'm going to take 1 hour to do this. I'm going to generate 1 more hour. And the reason why it was taking more hours is one of my inputs in the middle of this conversation was keep them as random as possible and keep them as diverse as possible. Don't keep repeating the same questions. Don't keep repeating the same line of thought. And you'll see that in the response. Initial questions that came up were, I'll show you some of the examples, right? You will find a lot of initial questions around just finances, financially healthy business, and things like how can I improve cash flow. And I wanted it to not just ask finance questions. I wanted it to ask questions beyond finances, right? Like, hey, is my product price right? Is my say how's my payroll doing? Am I paying the right amount to my employees, right? I wanted it to expand into other business functions and not just rely only on finance. So understood that input, and that's why it started taking that, hey, I'm going to go more broad, get more types of questions in the more different types of questions, and share them one by one, so that you can also take a look at how the batches, how the output looks like. So some of these were very interesting even for me. It gave me a tiny peek of how the response is going to look like, and then it went on its own execution mode. It took me an entire day to create this, by the way, though it said just 1 hour. I did a lot of back and forths. I understood the golden data set in terms of uh, does it match what the customer would look like. In fact, I showed some of these answers to some customers and asked them, hey, is this what you really want? Does this make sense for you? Does this response really make sense for you, or is this something else that you want, right? So there's a lot of back and forth in terms of, because I myself am not an expert in this space, so a lot of back and forth in that way. And eventually, let me see, just to fast forward a bit. So you'd see these kind of questions, right? Eventually it started populating these questions, right? How can I improve my customer retention? That's the Uber question. So one of the basic sub question would be, what is my current customer retention rate? What is the customer lifetime value? What is the repeat purchase rate? And then it'll also do external questions, not just internal questions. It'll do external questions like, how effective are loyalty programs in my industry? Do some research on that, right? So these are the questions that start creating. Let me see if I can show you some golden answers also it created at the end. So it interestingly tried to create a zip file which didn't work. So I had to ask it to break it down into smaller chunks and give me, which it did. There were a lot of back and forths. It initially gave me only 10. Then I said, hey, you're supposed to give 30. Why? How come you're giving 10? And then it said, oh, I made a mistake. I'm going to go get 15 more, 20 more. Just seeing if it has a. Okay, let me see. So yeah, I'm not able to get the golden answers, but essentially I'll take one question and I'll tell you what the golden answer was, right? So is my pricing competitive or should I increase, right? So it went, identified the margins. It went and so it gave a start with summary. It said that hey, you should increase or you should not increase. It will give you an answer saying you should increase or you should not increase. Then it'll talk about how it made that decision, right? Based on benchmarking against industry, based on current profit margins and the goal that the company should ideally have. It would make it'll get facts, do benchmarking, and then based on that benchmarking it would say that hey, this is my reasoning behind it and therefore you should increase. Though one of the other things that I prompted it is it should not just say whether a price should be increased or not. Can it also be increased by some x% or y%? Yeah. So yes, I saw this question from Praveen, so just interesting question, right? Yes, async is enabled on ChatGPT. A learning for me as well. I did not realize that you could do async work on ChatGPT. So you could give work. But it gets to decide whether it goes in the async mode or not. So it will tell you come back after an hour, come back after 2 hours, come back after 5 hours, and you could generate such. Cool.
One other question.
Yeah.
If the AI is also generating the answers, how do you know if the answers are right?
That is where the product manager and the customer understanding comes in, right? So one is we are starting in a blank slate, right? Earlier, if I were to create such an eval data set, that itself is going to take like few months for me.
Yeah.
Now I don't start at a blank slate. I start at something already written. Now I can use my business knowledge to improve this golden data set, which I did. It gave me an answer, which I improved. And later I could also throw it at a bunch of customers and tell, is this what you would expect as an answer? And they gave me a lot of feedbacks saying that, no, I would not want you to predict. Like for instance, it was a customer feedback who said, hey, if I ask you to whether if I should increase my product's price or not, I would want you to not just tell me yes or no. I would want you to tell me by how much or by how much percent. Right? So this was not originally part of the golden answers, goldens that were created, right? So you go back, talk to a bunch of people, and that is what is the complexity here. All of this is very, very subjective. Even the benchmarks out there are very subjective, though we think that benchmarks are very, very clear and everyone knows this is how the benchmark data set, everyone agrees on the answer. That's not the case. A lot of answers people don't agree, the reasoning behind it people don't agree. Maybe the end answer they agree with, but how that answer has to be derived, the steps are different, right? So there's a lot of subjectivity here, and that's where you can use AI as a partner to start building data sets, but then you have to take it to the customers, take their perspective to create the initial data set. That's number one. Number two, you keep iterating on this, right? The data set, like what we've learned from the traditional benchmarks that were used by OpenAI and all is they started building on one benchmark, they threw it out of the park, they hit 95%. Now they move to another benchmark, right? So you keep improving your benchmarks, you keep building new benchmarks so that you can keep iterating and keep getting better and better eventually till hopefully at someday AGI comes. Yeah. Cool. So that's on creating benchmarks. So if you see, I created synthetic data, I built golden answers. What I didn't show you is I also rated these answers. I took some sample answers from the agent itself and I rated those answers and said that against my golden answers, I would give a rating of 0.5 for this or 1 for this, right? And based on a rubric that I created. A rubric would say if the answer is very comprehensive, then I'll give it 0.75. If the answer also includes a summary, then I'd give 0.25, right? I'd create a rubric or some kind of a scale on which I would rate the answers. manually. Now, why do this? We'll talk about this when I talk about LLM as a judge. Why a rubric is important, or why rating and having a logic behind why those ratings are important. We'll talk about it when I come to LLM as a judge. But now I'll move on to the next one, right? The next one is programmatic evaluations. This is the most underrated evaluations, I feel. It's so easy, but it's so underrated. People miss it all the time, and this is something that I keep trying to see if, because it's so cheap and it's so easy to get, right? For example, let's take the same example, right? Natural language to SQL. If the SQL does not have syntax error, that in itself is a win, right? If the SQL that it generates, or let's say natural language to code, right? If the code does not have, if a code is compilable, code does not have syntax error, that in itself is very easy way to say that the model is at least working to some extent, right? You don't need to create a benchmark, you don't need to get humans to rate it and all of that, right? Very cheap, very easy to get. What are some more easy ones, right? So summary one that I was building, right? We were trying to create a summarized answers. So an easy way to check is if the summary is less than 200 words, that's great. If summary is greater than 200 words, that's not great, right? So that's an easy way really to check how well the agent has performed. Is it meeting my expectations or not? You all obviously want to check the quality, but then there are much more easy unit tests and programmatic evaluations that you can do that gives you, at least in the initial stages, right? Before I have a benchmark, or before I know before I have a good data set to evaluate, I can easily have these programmatic evaluations to know whether my agent is performing going in the right direction or not. Is my agent even generating compilable code? Is my agent generating summary that is that people would even want to read or not? If summary is great, is 1,000 words, people would most likely not read it, right? The summary is just say 50 words or 100 words, then people would read it. So use this initially, that it'll really help. uh, a great example of this is how Cursor and Windsurf use it. So what they do is they go and look at code commits on GitHub. For each of the code commit, you would typically have two things, right? There'd be an intent that would be published, and there'd be some unit test case that would be published. They would remove the code, use the intent, generate the code using Windsurf, and see if it passes the unit test. Literally comes free, right? You don't need to worry about creating a benchmark or eval. Programmatic evaluation, you have unit test cases out there, literally comes free. So this is super underrated, but I would really suggest try to think out of the box as to how you can bring in some kind of deterministic tests that you can use for agents, because all of the other tests are going to be super subjective. Next one is system performance. Not going to go into too much details. I'll show you a small demo in Langfuse as to how this is measured. So system performance is largely around observability. Are there errors? Is the LLM erroring out? Is the API is erroring out? What is the latency? What is the cost? You might want to measure all of that as well, because based on your use case, you might want the answers to come faster. Users may lose interest if the answers take like 4 hours. In some cases, users may wait. Like for example, deep research scenario where users are willing to wait because they get high quality answer. But let's say you want to get quick answers, then you probably want to keep a tab on those latency and costs as well. Fourth one is human in the loop and LLM as a judge. Again, I'll show a demo for this, but what does human in the loop and LLM as a judge do? Human in the loop is the traditional one that we were doing, right? Even in the predictive ML cases, I told that you give a bunch of data, ask humans to evaluate the data, give their outputs, and then you use that to test a model. Now, in the agents world, what you do is each of the agent traces or each of the agent trajectories, right? You show it to some humans and ask them, is this the right way to experts, right? Humans here are experts who understand how the agent should have ideally worked, or how a user user would have gone about it if he were to do it by himself or herself, and then the expert would rate if it's good or not. Obviously, it's super costly. You cannot get every single trajectory or every single trace that you have evaluated by human. You could still do like a percentage of it, maybe 5%, 10%. There are techniques to figure out which ones are most likely wrong and get those evaluated, right? We'll talk about that as well as we're doing a demo. The alternative to this is LLM as a judge. This is getting very popular. This was not available earlier, right? Earlier, when we were doing predictive ML, oftentimes we would not use one ML model to evaluate another ML model because we felt that the ML model would compound the errors. So let's say the original ML model had X% error. You use another ML model which also has an Y% error uh, to evaluate the first ML model. Then so it would give you some answer as say the accuracy is 50%, 60%. That is a combination of X and Y. That has a lurking factor of X and Y, right? Because the other ML model also has some errors, right? But that paradigm is changing a lot with LLMs. LLMs understand and really adhere to some of these rules or rubrics that humans give, and this is where the rubrics start coming in, right? Now, what does LLM as a judge do? LLM as a judge, you can take these goldens and these rubrics and give it to an LLM and say, hey, these are some sample questions and sample answers, and this is how you should rate answers, right? Now, here's a new answer that has come from an agent. Rate it based on your understanding of these golden answers created by humans, the rubrics created by humans, right? Now, LLM as a judge can largely adhere uh, uh, to this model and try to make sure that it uh, really uses these goldens, these rubrics, underlying rubrics to generate answers, right? Let me see if I can actually show you a rubric. I think that will give you a little more. Mm, just a second. Let me stop sharing. I'll try to find the rubric. The rubrics are very interesting. Here's a rubric, right? Did understand the intent correctly? Some points for that. Did the decomposition happen correctly? And you can also separate these as different LLM judges also, right? There could be an intent understanding judge which just says, hey, whether the underlying core intent was understood correctly. Was there the sub question decomposition, did that happen correctly? So you can create rubrics like this. You can create specific criteria, specific ways. You can be a lot more detailed about this, right? You can actually talk about, while decomposing, I need at least 8 questions. 4 of them should be internal questions, 4 of them should be external questions. um, Most of the 4 questions should be related to the underlying topic, just finance or marketing or things like that, right? You can make it much more detailed so the LLM understands the way you are evaluating or way you need evaluations and appropriately incorporate it, right? um, with that, what I'll do is, just to make it a little more interesting, let me go into showing a evaluation, right? So this is the any questions? Should I take any questions now or before I go to the next demo?
Up to you.
Okay, I don't see hands raised, so I'll just go to the demo then. Okay, there is hand raised. Yeah, Vishwa.
Hi, Jimmy. My question was regarding answer accuracy. So, in LLM as a judge concept, how will the architecture look like? So, the judge will also have access to all the database and all the queries, everything. Will it be just a mirror of the original LLM agent?
No, no, no. It will not have any of the answers. So it is just what it will judge is it will judge the input and the output largely, right? Let's say the question is, how do I plan can you plan a trip to Delhi, right? It'll take that question and then agent will generate a response. It'll evaluate the response with that question based on the rubrics or based on the sample evaluations that you've given. That's what it do. It does not have access to the tools. It does not have access to the prompts that the agents are using. It doesn't have access to any of those.
So, in that case, answer accuracy, how does that work?
So that's where the rubrics come, right? So you kind of say that what you have to define that this is what I mean by an accurate answer, and that's where it's a lot subjective, right? It's very hard to wrap our heads around. Hey, it's not like a 0 or 1, right? You kind of define an answer is accurate if it's, say in this case, an answer is accurate if the trip plan includes both flight and hotel. If it includes cab bookings as well, if it correctly has adheres to the start date and the end date, right? So you include some of these as accuracy rubrics, which the agent LLM as a judge uses to eventually evaluate whether the answer is correct or not. And not to say that will be exhaustive, right? So never worry about being exhaustive, because you can never be exhaustive when you're building these LLM judges. As you interact with users, as you learn more from users, you keep updating the LLM. So have that mindset of you're in a continuous evaluation mode. Don't have a mindset of, hey, I created an evaluation, that's it, I'm done. Even people like OpenAI are doing, right? They keep improving their evals. They keep changing, like we talked about. They keep changing benchmarks. They have LLM as a judge. They keep improving that also continuously. It's not like, once you're created, that's it.
Okay, thanks.
Okay, so again, I've taken a sample notebook here that kind of built, from one of the Hugging Face notebook codes. So, and before that, what I've done is I've gone to just log into Langfuse is one of the tools. All of these tools use OpenAPI tracing, which is the open standard about how you trace different agents. Langsmith is one tool. I think Bala demoed that some time back. Langsmith is not open source and it's costlier. Langfuse is a little cheaper, um, and also since it's open source, you get some free credits and whatnot. So that's why I've chosen Langfuse. For that matter, you can even go to OpenAI portal and you can use them also. OpenAI also has something called evaluations. You can run your evaluations here as well. So nothing like an evaluation has to be done only in Langfuse. These are all, think of these as different front ends which have different features, different capabilities, but the underlying traces are largely standardized to the OpenAPI tracing standards. Okay. So I'll just run some of these codes, right? So here, they're very simple agent. It takes some questions, uses internet to generate some answers. That's what this agent does. This is not a very complex agent. I'm using small agents here, and that's because this notebook uses small agents. Small agents is open source framework by Hugging Face to build agents, something very similar to LangGraph, right? LangGraph is a little more controlled. Small agents is not so much controlled. Small agent lets the agent go crazy. It can choose whichever path. LangGraph is more controlled. LangGraph, you design those conditional paths, say that, hey, agent can choose only these 2 paths, or based on the output can choose only these 4 paths. Small agents is not like that. It allows agent to go crazy. You can choose any paths, any tools that it has. And the other interesting thing about small agents is, for instance, your LangGraph tries to create API signatures when it is calling tools, but small agents creates code snippets when it's trying to create tools. So the tools, all the tools here typically accept code as an input. So let's say there's a tool which can write code, right, or which can compile code. So a code will be generated to invoke that tool, not an API call, right? So that's one minor difference, right? So let me just show you. So I went to Langfuse, created one project. So you create your own org, then you create some project under that org. In Langfuse, you get 2 keys. There's a private key, there's a public key for the projects. So once you have those keys, I just added it to my Collab notebook, so that it'll automatically take those insights, those keys. So whenever a trace is created, that gets passed to my project in Langfuse, and I can start viewing those traces in Langfuse. So this is just getting those basic libraries installed. You have your small agents telemetry library, then open telemetry. There's the open API spec that I was talking about. Some sample data sets. This is done. just go a little fast so that we can cover as much as possible. So I'll share this notebook. You can go through the code in any free time. Mostly it's boilerplate code. Trust me, it might look very complex. All of this boilerplate code, copy paste. You can copy paste most of these codes into anything that you're building, and you can reuse it. So here is an instrumentation I'm testing. So quick overview of how this works, right? If you go to your any project, these are the different things, right? The home shows a dashboard for that project. What is the model cost that is incurred? What are the different traces that I have? I have generated some of these human in the loop evals. I've also this is a human in the loop eval. I'll show you how I created that. I've also created the judge LLM, which is measuring correctness. It shows trace by time or usage, some standard observability metrics. So that's one good thing. You get these out of the box. I didn't create these dashboards. This is out of the box. You can also create dashboards if you want. If you want, certain specific dashboards, you can create that. That's in beta. Now let's look at the traces, right? So this is the latest trace that I ran, 1048. So what this trace is done, and some technical terminologies again, this entire thing is called a trace. One particular thing is called a span. That's again normally accepted thing. For some reason this is errored out. I don't know why. Let me try that again. Okay, I think the libraries are not properly installed. Let me. Oh, okay. Unfortunately, I think I exceed my free credits. But I'll quickly walk you through what I've done here. Anyway, in the interest of time, right? I'll walk you through. I'll open an older trace and I'll show you what happened. Let's say this trace, right? So this is basically a simple task. If you look at this trace also, if you look at this question also, all it asks to do is just do a 1+1, right? So here, this is the input, this is the output. So it is showing what all steps were done. Nothing complex here. You just have the age without even calling any tool call. It gave you an answer, right? So it goes to the thought, action, observe. So it thought about the question, generated the answer, gave the answer back to the prompt, and then the prompt had the answer. It generated the final answer. The final answer tool is the one that gave the answer as 2. So that's what this is doing. But what I'll call your attention here is we'll talk about the score and correctness in a bit. But if you look at for each of the span in the trace, you can look at what is the latency, how many input tokens were there, how many completion tokens, output tokens were there, what was the model used. So this is technically a free model. That's why it is not showing the cost, but it is supposed to show you cost also. If you're using a OpenAI model, for instance, let me see if I have an OpenAI trace. See, I have an OpenAI trace. This is a one that I ran in OpenAI, so it shows the cost that I incurred for running this particular agent. Now you can go into more complex questions. So this one, the next one I wanted to show is how we are using a search tool. Simple thing. So let's say how many Rubik's cube or some types of cube that you can fit in a Notre Dame cathedral. So the way this kind of did is it tries to first of all identify the size of Notre Dame cathedral. So that is what it is doing. So it realizes that, hey, I need to find out the cathedral dimensions to really understand how many cubes can be fit. So it goes, does a bunch of search, identifies the size of the cathedral. It has gotten the size 130 meters, 48 meters, 35 meters, and then it uses this combination to run a code to figure out just a division code to figure out how many uh, cubes can be filled. This is what it does, right? So let's look at the trace for this. This is the trace. So you can see, what was the input, what was the output in these traces, and I'll tell you why this becomes important, right? You can see what were the observations, what were the tokens, latency, overall latency, what was the cost, all of this information over here. So if you look at over here, you will see that how they were model calls. There was also a tool call here. You can look at the time taken for the tool call, and you can also see how the model is been executing, right? How it finally came up with the answer. So you can see all of this, what exactly happened. Interesting thing is this timeline mode. So it'll also show you in timeline how each of the steps took, right? So this took, when I ran this, it has taken about 28 seconds, and how each of these steps broke down. The model call, then the API call, the tool call took so much time. Then using the tool output to generate the necessary Notre Dame size, that took majority of the time, and then the final division took about 5.6 seconds. Okay, let's talk about the remaining things, right? That's where it gets more interesting. So one is, if you go to data sets, you can see that I've created a sample data set. What I can do is, as I get more and more data over here, I can add it to my data sets. Now, what this does is, if I find some really corner case that people are using, right? It's like once I go to production or I'm in alpha and I find some corner cases that people are using, I can add this to the data set, and I can use that data set to further evaluate in future my models, right? Like let's say I do an upgrade, right? This could act as a goal to evaluate how well my model is performing. So you can create a new experiment and just follow the steps, pretty straightforward. Create a new experiment and then evaluate how well your model is performing against a new data set or an enhanced data set based on data use, right? You could also score this, right? Let's say I want to annotate it. This is the human in the loop, right? I send this to what I've done is, in my human in the loop evaluation, I've created another human in the loop trial data set, right? So here I can add, so let's say I go to the traces, I want to do human in the loop evaluation for a bunch of these. Let's say these I don't want to do, I want to do for these. I can just add it to the annotation queue. So once I add it to the annotation queue, any human who has access to this, or any expert who has access to this, can go through them one by one and give a score. Okay, this is good. This is 0.5. This is good. Complete and go to the next. This is bad. Say 0.1. So now what I'm doing is I'm using real-time data to generate how well each of the input-output combinations are. This can again be sources to in the evals that we are talking about, right? So because we have to constantly keep improving our evals, we have to constantly keep identifying corner cases, how based on how people use, we can evaluate this through human in the loop and then push it back into the data set that I spoke about. And that data set technically needs to have both positive and negative cases, right? So these could be negative cases that you have, and that could be used to test your further iterations. You bring in a new model, you update your agent, improve your agent, you can test it against the enhanced data set to see how well the agent is performing, right? I'll also talk about LLM as a judge. So unfortunately, this allows you to create only one LLM as a judge. So I need to delete this to create a new one. So I can create an LLM as a judge. I can create a new template also. I can say that, hey, what do I say? I'll use correctness only. I'm not able to think of anything good. Compare the answer. Zero. This can be really a basic one, but this is where you are typically trying to add your rubrics that I spoke about, right? Now it could be, let's say you have an obscenity uh, LLM as a judge, right? That's what you want to measure. You can say how you define obscenity as in terms of when people use certain cuss words, let's say that's obscenity. Whereas, and you have to be very nuanced about it, right? Someone might say, "Oh, that was fucking hard," right? Technically, that's, you have used an obscene word, but that's not in an obscenity context. So you can add that information, and LLMs are pretty good at understanding some of these. As LLMs are improving, they're getting better and better at understanding some of these. So you can choose your own LLMs. Here they give you some of the free LLMs that they've already partnered with. You can choose that and you can add it. Okay. Yes. Correct. So there is some reasoning paths you want to give. 0 and 1. Let me go to LLM as a judge. So this is something that I've created. I can just go ahead and create this. So this becomes active. So now the question is, how does this get invoked? This always gets invoked. The moment, so today the way Langfuse works is it does not invoke only on certain scenarios. So therefore it might be costly if you're using a costlier model, or if you're using a reasoning model and all. But today Langfuse does not allow you to invoke it for a say 10% or a 15% sample. Unlike human annotations, you could actually click on annotations and send it into a queue for annotations. Here, what would happen is the moment you invoke that, every new run that happens, say here the question is, what is the capital of India? The answer is New Delhi. So here you can see that the correctness is 1. This correctness is based on the LLM as a judge. And you could export all of this, and based on if it is correct answer, again you could do the same thing, right? If you find that LLM as a judge is given as a correct answer, this could be moved into your sample data set, eval data set, to test further. And the last one I wanted to show, which I'll just cover quickly, is you can also take user feedbacks. So you can take the thumbs up, thumbs down, star ratings. There's one problem with this. People end up giving only negative feedbacks. Typically, they don't give positive feedback. This is based on a lot of tests that I've done as well. You often don't see people giving negative feedbacks. So a better one would rather be to use implicit feedbacks. Like if they copy an answer, or say if they retry something, or if they ask follow-up questions, those are good. And recently, ChatGPT introduced a very interesting pattern. At the end of So at the end of every question, if you notice, ChatGPT would ask a follow-up question. This is a great way to get feedback, right? Let me show you here, right? So it generated some of these, and then it asked me a follow-up question. I can also do this. If you want to generate more, would you like to create this? So it asked me some follow-up questions, right? The moment I start answering yes to it, this is also feedback that it gave a right answer. It gave a good answer, and I'm actually I like this answer, and I'm asking it to give me more information, right? So explore these techniques as well. I'd love to demo this on Langfuse. I know we have over time, so I'm going to skip that. But explore. Don't just take explicit feedbacks. Explicit feedbacks typically are more used when there is negative feedback. That's what I've seen in the limited experience I have in building agents. Implicit feedbacks are much better. See how you can get people to use things like download, copy, retry, ask follow-up questions. Those are multi-turn conversations have proved out to be better to get feedbacks as to whether a user likes a response or not, rather than relying on singleton feedbacks, singleton answers. Great. I know I'm over time, so I'm going to open it up for questions. Actually, just
Yeah, if you already.
so I also wanted to leave you with something to read. So let me. So keep in mind, evals have to be updated continuously. Be precise. Don't make the metrics too subjective. Be as precise as possible. But at the same time, it's an evolving space. So keep adding, keep evolving your evals. Don't try to just do uh, standard evals. Combine offline and online. And some good courses to do is Hugging Face as an agents course. I really like it. And weights and biases. That's another tool, by the way, similar to Langfuse. They do a bunch of observability on LLM building and all. They have an apps evaluation course. That's again a good course to do. And there is a YouTube video. I'll share this link with Bala. There's a YouTube video on how to set evals. That's where I started a few months back, and I could eventually catch one by one and reach here. Yeah, that's all I had here.
Got it. Let's take a few questions. Yeah, probably the first question from Shritish. We want AI to be better than humans. Why should benchmarks mimic humans and be human-like?
Yeah. Okay. So I'll just add a few points here. So see, we all see that we want AI to be superhuman, right? And do tasks with more accuracy in medical science, like in defense, in like many other areas. So very basic question. I understand. I mean, it's very difficult to evaluate if otherwise. But why should benchmarks just why are we pushing them to be human-like?
We're not pushing benchmarks to be human-like. So it depends, right? So what you're talking about is research level AI. What I'm talking about is more product use cases, right? I'm talking from a PM perspective. For product use cases, I want to replace the work that humans are doing today to make it much easier, faster for them. That's why I'm pushing my benchmarks to be human-like. But then the research benchmarks are more complex, right? You need to think about this in the space of what you don't know that you don't know, right? Typically, if you don't know, if let's say the protein structure that LLMs identified, you don't know to even create a benchmark for that. How do you create a benchmark? So
Right.
you can only create human level even if you want, can you create inhuman, like beyond human level benchmarks? At the end of the day, we are humans, right?
Yeah. Yeah.
Even if we want, we can't do that. So yeah, that's a research topic. If we end up doing that, then that's already human level. That again talks to the topic about how evals are evolving, right? If I can actually find a protein structure, which then that's no longer that's human like, that's no longer beyond human level, and that can be added to my eval. So yeah, combination of AI, humans, keep improving your evals. Especially research space, it's a little more complex. But as we are building regular products, try to get as much information from regular users and human like behavior. That could be a starting point. Think of it that.
Sure. Yeah.
The next question is something I like. This is something I have faced. Customers would have varied opinions on like what the answer should be. So how do you suggest something as a golden answer?
Yeah, this is super subjective, right? What I have been using, and I'll tell you from my experience, right? So I try to do a lot of customer interviews, show them these answers, and then take majority answers, right? And if there is oh, there are some deviations, right? I try to understand the customer's perspective, right? So maybe that's because some customer has certain perspective, right? For example, let's take this travel question, right? Someone might want more cheapest flights. Someone might not want cheapest flights, more convenient flights, right? This is a standard case of subjectivity, right? So this is where one is, you try to get, hey, what's more likely that people will want, right? Most likely people will want cheaper flights, right? But some might want on-time flights.
Yeah.
In that case, what we try to do is we can introduce some of these personalizations, right? So if the user has been using that tool before, or user has been using that system before, we can bring in that user context from the memory and add it to the judge. Say that this user typically likes more time, on time or time based flights rather than cheap for flights, right? So the judge LLMs doesn't have to be set in stone that hey, they use always the same prompt, always the same thing. You can also be a little more smart and get memory and personalized information about the user, pass it into the judge LLM prompt while evaluating and getting the answer.
Got it.
But have you seen this happen in let's say while you're writing actual eval? So what you're saying is you'll have different evals for different questions based on different personas. Now, does that how you do it right now, or is it?
No, it's a single eval, but the prompt that is going to be used, you have a in-memory context that gets added to the prompt. So it's the same model, same workflow that runs. It is just that you add the prompt changes. That is something that I have seen.
Okay, got it.
Prompt adds more context.
Got it. Next question. Typically asked. So with respect to the demo itself, how did we link the small agents to Langfuse?
No, we did not. Okay, so
How does the traces like hit Langfuse? That's
so when we use that keys, right? I'll show you. Just share my screen. So this is where he started. These code snippets is where we linked.
Okay.
The keys. Then we are exporting it to the Langfuse host, and then we invoke the traces.
Got it. Got it. Got it.
So every LLM call gets,
Every trace automatically goes to my project in Langfuse. Every call,
Even Langsmith was very similar.
very similar. Yeah. And again, this boilerplate code, by the way, copy paste.
so
Yeah, I mean, Anando's next question is also kind of answered with the same thing. So I'm going to skip that. How to restrict evaluations for certain set activity in Langfuse?
I do not understand. Sorry.
Even I don't understand. Ranjit, are you here?
Yeah, no, I was just trying to ask, like currently, we are tracing all the activities, right? If you want to, for example, certain activity or certain input output is important thing, and that needs to be evaluated specifically or something of that sort. If you have to restrict something of that sort, we don't want to actually track all the LLM calls and other things. We want to restrict to certain set of activities to track. Is there a way to track only those set of activities and give more weightage to those things?
Yeah. So there is an option. You can create some tags based on if the question is a certain type of question. You can automatically create some tags. I'll again show that also. So if you see here, I created some tags, right? So if these questions are all related to some cities, right? So what is the capital of India, right? I can create some tags on these, and only those tags I can filter and send for annotation, send for some other reason. All of them will get traced, all of them will be tracked, but then any additional work that I want to do, I can use these tags to automatically send it for that additional work, which would be human in the loop, which would be maybe something else that you want to do. Maybe add it to a data set which you want to use as evals.
Okay. But we can't do it at the code level. But we have to do it only like come to the Langfuse and then do it that way.
No, at the code level also. It is possible. What I'd suggest, Ranjit, is take a look at the Langfuse documentation. It has just for tags in Langfuse documentation. It will tell you how it can be done at a code level, but it's quite crude, honestly, right? It relies on some LLM kind of tagging a particular use case in a certain way. It's not foolproof.
Correct. Okay.
Awesome. I think that's all we have for today. GMK, thank you so much, Ra. This was very, very useful. I had no idea about this before. Very happy that we were able to get you and have this session. Really appreciate it.
Thank you. Hope it was useful, guys.
Yeah, thank you, Langfuse.
Thanks, GMK.
All right, everyone. Have a good weekend. Bye bye.
Bye.